What's up, 7th graders? It's Mrs. Talati here, representing Mrs. Servati, and now I'm going to cover 7.2, which is writing two-step inequalities. Your essential understanding for today is I can write two-step inequalities given a real-world problem. Now, this chart, if you will, is a really good place to use and add to as word phrases start to pop up, okay? So as you guys can see, it has the basics that are in the meaning category. So less than is less than. I'm also going to add that it is an open circle, right? And then word phrases that might also pop up would be fewer than or below. So again, as you see these pop up in word problems, you can add them to this chart, okay? So open circle goes here, and then here we're going to add in that it's a closed circle, remember, because it has the equal to added into the inequality sign, also known as at most or no more than for less than or equal to, and then at least or no less than for greater than or equal to. So again, today should be fairly easy because now we're just translating word problems into inequality statements. Now, if you guys go back, I want to point out that this is a two-step, right? So that means we're going to have two different operations, whether it be addition and multiplication or subtraction and multiplication. Just remember there's two operations and an inequality sign, no equal sign as you write these. So the first problem, a mountain climbing team is camped at an altitude of 18,460 feet on Mount Everest. The team wants to reach the 29,029-foot summit within 6 days. Okay, writing inequality to find the average number of feet per day the team must climb to accomplish this objective. Okay, so the first thing is we have to identify what we're trying to find. In this case, we're going to use D for our variable because D is going to represent the average altitude. Let's write it like this. Average altitude the team must gain each day. Okay? So as we go through these, we're going to identify, and this is going to be a key point here, that this is the number that's going to get the variable. So I'm going to, dang it, I didn't leave myself very much room. I do this all the time, I know. Let's write it like this. Okay. You guys, I'm going to have to erase this. Just make sure you have it written down because I'm going to write it out in words first. Just to make it make a little bit more sense. So I'm going to put here starting altitude. Then I'm going to have plus number of days times, let's use the word. I don't want to get confused with the dot. Altitude gained is great. See, I'm still going to run out of room. Is greater than or equal to target altitude. Because in that way, I can kind of fill in my numbers. If you guys see that we were at 18,460 feet to start, we're going to add that. If we cover it for 6 days, we're trying to find the average altitude gained is going to be greater than or equal to the target altitude, which is this 29,029 feet. So again, we're only writing these, not solving them. Now I also want to point out that with commutative property, I can also write it this way. I mean, there's multiple ways you can write it. In the end, we have to make sure that our sign is going to be greater than or equal to. So a mountain climbing team is camped at an altitude of 18,460 feet on Mount Everest. The team wants to reach the 29,029-foot summit within 6 days. So again, we have to identify that it's got to be at least that height, right? Because that's what they want to attain in their hike. Okay. So now we got to figure out how to write one of these. And really, you guys got really good good at writing the two-step equations. It's now just identifying, instead of an equal sign, that we're going to plug in an inequality sign. Let's go. So this one's 2x plus 20 is less than or equal to 50. And I'm trying to think of one that, let's use one that's out of the textbook. So this one is going to, oh, they gave us two different scenarios on this. I like the first one because I'm a runner. So let's say, let's set these goals. Mrs. Talati, we're going to set a goal right now, but this is definitely not happening until we get into closer to RTO training time. Okay, let's say that I have ran, Mrs. Talati has run, see why I teach math, has run 20 miles, right, that's the initial right there, so far this week. That I could do. It wasn't snowing so much. If she intends to run, what am I doing? 2 miles. Oh no, I want to go 50 miles or less. Right here, because this is less than or equal to, right? My spacing is off today. How many miles on average should she run on each of the 2 days remaining in the week? And there's so many different ways you could write this. I mean, you could have said, in January, Mrs. Talati ran 20 miles. If she runs 2 miles a day, when will she hit at least 50 miles? Or at most 50 miles. No, that's not a good one. This one's actually better. Now that I say it out loud. So Mrs. Talati has run 20 miles. That's the initial. So far this week, if she intends to run 50 miles or less, how many miles on average should she run on each of the 2 days remaining in the week? I think the part that's throwing me off is the less than. Another example they gave in the book is items. So Manny buys 2 work shirts that are each of the same price. After using a $20 gift card, he can spend no more than $50. What is the maximum amount he can spend on each shirt? So there's 2 examples that kind of help you get going. And then you guys are going to set up 3 and 4, and then try and write. And you guys can use the examples of the running or whatever it is. I think the most difficult part is figuring out, like, this is going to be your greater than. And then this one's going to be your less than or equal to. All right? All right, you guys, we'll be practicing this in class too. I miss Mrs. Cervantes. I get lost in talking to myself. You guys have a good day.